we have the same learning goals today that we had yesterday? I can find the probability of independent and dependent events. So what we're going to do kind of in the beginning here when we're comparing and contrasting is we're kind of like summarizing what did we learn yesterday, okay? So independent events is in one column, dependent is on the other side, and in the middle they're telling us how can we compare them? How can we see how they contrast? Contrast means what? How they what? Differ. And compare, sometimes comparing can also be thought of as how are they different, how are they the same? And so in this one, hopefully there'll be some sames also. So independent events, in the definition, they've already done that for us. No, we have to fill in, it looks like some words here. So in an independent event, the definition of it is the occurrence of one event blank the probability of the other. So I'm going to give you a choice, kind of like a word bank to choose from for what is it that I'm looking for here. Affects the probability of the other one, or does not affect the probability of the other one?
Does it not?
Okay, in an independent event, it does not affect. So we're going to sneak in those words in there in that white space. Does not affect. Okay, go ahead and start writing that. The occurrence of one event does not affect the probability of the other. Well, when we contrast that with the definition for a dependent event,
it does.
The occurrence of one event does affect the probability of the other, doesn't it? So that is where they differ. One affects, the other one does not. When it's dependent, we have one is dependent upon the other. Its probability is affected by the other. When it's independent, you know what? They work independent of each other, and they don't have to worry about what happened to the other one. Okay. The next thing we want us to contrast is there a replacement? So remember I said, look for those key words. So in an independent event, is there a replacement?
Yes.
Yeah, in that one there is a replacement. Whatever we were finding or choosing got replaced. It got put back in the bag, it got put back in the pile, whatever, it got replaced. So in an independent event, we do replace. How about in a dependent event? No, we do not replace. So there is not replacement. Maybe you should circle this in the middle so you can see what are we answering yes or no to. Shamarki?
So the independent, that's the one you put back, right? If it was asked a marble, and it said you take one out and you put it right back in, that's the independent?
That's the independent. So you pick a marble out of the bag, you record what you got, you put it back in, you replaced it, so it's independent.
And if you don't put it back in?
If you don't put it back in, you set it aside, now that's dependent. Your next draw is dependent upon that. Okay? Anybody else? Any other? Okay, so when we are finding the probability of two events, A and B happening, so we have the probability of A and B happening, what do we do? Does anybody remember what we do? Can you give me the mathematical way we wrote that, Malcolm?
We do example 1 over 2 times 1 over 9.
Yes, we find the probability of each of them, right? And we multiply them together. So here's how we do it. We say the probability of event A happening times the probability of event B happening. And we can figure out the probability of each of them separate of each other because they're independent of each other and just multiply their probabilities together. Well, what do we do when we are finding the probability of two events A and B happening, but it's dependent? Cameron?
Probability of A times the probability of B after A.
Yeah. The probability of A, because that gets to be first, so it's not affected by anything, and then times the probability of B after A. In other words, you got to figure out what's the probability of B happening, considering that A already happened. So how did A affect what's going to happen in my second event? So that B after A is really important. It isn't just probability of B. Okay, so those are kind of like their differences, right? That seems to be what their differences are. Now, I'm guessing here, when they say compare, it says both formulas involved. How are they alike?
They both involve probability.
They both involve probability, yeah, but that's what we're finding. We're working with probability. But what do they both have? What operations do they both have? Rose?
I was gonna say events.
They both have events, yeah, because in probability there are events. Right?
You end up timesing it A and B.
Yeah, you still do multiplication, don't you? Both formulas, both of these things that we just talked about here, both have multiplication. So you have to make sure you multiply the probabilities together. And our last one, well, how can they be alike? Kind of like what I think Rose was just saying here. There can be, they both have events. So we're going to say both situations can involve two or more events. Two or more events. So when two or more events are going on, we have to decide whether they're independent and dependent, but in both cases, there's at least two things happening, okay? So now let's go down and do some practicing, like let's just, like this is what we were doing yesterday. So Ben rolls a 3 on a number cube, then he rolls a 4. Now notice, sometimes they don't use the word replacing, because they don't need to. If you roll a number cube, does a number fall off and disappear? No.
We practiced that very
Did you?
diligently this morning.
And did the number ever fall off? Did you do enough trials that, the number fell off? You thought it did? Oh. Okay, I want to see it happen, okay? You show me that it happens and then I might become a believer. Okay, so what kind of an event is rolling a number cube and then rolling it again?
Independent.
It's independent. What you roll on the first and what you roll on the second, they are absolutely independent of each other. What you want, that might be a different story, but one does not affect the other. Okay? Just because you roll a 3 the first time doesn't mean you can't roll a 4 or a 3 or a 5 or a 4, 2 or whatever. Okay? May chooses a prize out of a bag and she keeps it. And then Grace chooses a prize. Is that independent or dependent?
Dependent.
Dependent. Why?
Because she chose the Grace is not going to get
Okay,
the
go
same.
ahead, Malcolm.
Because she chose a different prize.
Because she chose a different prize. Well, why did she choose a different prize? I mean, could she? So you're telling me she couldn't choose the same prize that May did?
Or she she got a prize.
Yeah, because she can't choose the same. She can't choose the exact prize that May did because May didn't put it back, did she? Yeah, she kept it. She didn't put it back. So now the number of prizes in the bag went down by 1, didn't it? So this is a dependent event. So yeah, she chose a different prize. She didn't have the chance to choose the one May did, okay? Because May didn't put it back. Okay, Greg picks a red crayon out of a box, uses it, and then puts it back. Then Joe picks a red crayon.
Independent.
Independent or dependent?
Dependent.
Okay, I want somebody, if you think it's independent, then you better give me justification for it. If you think it's dependent, give me justification for it, and then we'll decide. What do you think, Luan? Which one do you want to go with? Dependent. Do you think it's dependent? Can you give us a reason? Because they took it out, okay. But didn't Greg put it back? Okay, Greg took it out, used it, and then put it back. And then Joe picked and wanted a red crayon. So dependent. You want to go with that? Okay. Josh? Independent? Why?
So,
Okay, put it back and nothing changes. Okay. Trey?
does it change from Greg using the crayon?
What do you think, class? Does it change from Greg using the crayon? Because it says uses it. That's why they threw that in there. They're trying to test you to see, does that affect the second draw?
The put it back affects the second draw.
Emerson?
But then Joe picks a red crayon, and Greg just put the red crayon back, so would it be dependent because Joe picked the crayon again?
But it was the fact that how many red crayons, or the red crayon being there, was that dependent upon the fact that Greg picked one? I mean, was there really like no red one there for her to pick then, or the number of red ones decreased by any, or that's what we got to
It's independent because Greg using the crayon is still a red crayon. And it says he puts it back and then Joe uses it. So
Yeah.
Joe waited for it.
Exactly, yeah. You know what, using it doesn't matter. Using it doesn't matter. Using it matters if he doesn't put it back. Then we could say, well, okay, well, then there was, but in reality, whether he keeps it or puts it back, using it does not matter at all in the deciding if it's independent or dependent. Trey?
What if he uses it and then it's halfway gone, or he uses it and breaks it?
Still a red.
Okay, this is the, we're going into the what if world. Now, does it say that Joe wants to pick a brand new, never used crayon?
No.
Does it say we started with a brand new box of crayons? No, all it says is, Ray picked out a crayon out of the box, a red crayon out of the box, used it, put it back. Joe picks it, wants to pick a red crayon. You know what, this is no different than a yellow marble in a bag. It went back in. The red crayon went back in the box, so this is independent. You get to put like an X through this and say, you know what, that really doesn't matter. Using it does not matter. What matters is put it back. So sometimes it puts some words in there that might throw us off. We gotta process through that. Okay? Okay, so now let's do some. So a bag contains these marbles. Find the probability of each event. So event 4. Probability of picking a blue marble, then another blue marble. So here's our A. Here's our B. With replacement. Is this independent or dependent? I want us to identify that first.
Independent.
Independent because,
He's replacing.
yeah, that tells us right there it's an independent event, right? Okay. So independent event, we take the probability of, what's the formula? Probability of A times the probability of B. So we need the probability of A and B happening. Well, both A and B are blues, aren't they?
Yeah.
So we really only need to figure out the probability of drawing a blue. So what is the probability of drawing 5 blue out of how many total marbles? 10. What does that simplify to? 1/2. And event A is a blue event. Event B is a blue event. So we're ready to do the probability of A times B. So we're going to do 1/2 times 1/2 equals 1/4. And 1/4 is what percent? 25%. So there's a 1/4 probability, also known as a 25% probability that a blue marble could be drawn out of this bag, replaced, and another blue drawn out again. Okay. Blue without replacement. Without replacement tells us what?
Without being replaced.
Independent or dependent? Dependent, right? Okay. And we already know the probability of getting a blue, right? But we need, you know what, we're going to do this though. We're just going to remind ourselves that the probability of getting a blue is 1/2. But we need the probability of a blue after blue. Blue after blue. Because it doesn't get replaced, right? So what is the probability of getting a blue after a blue? 4. We didn't put that one back.
4
And
out of 10.
It'd be
4 out of 5.
4 out of 9. The blues went down by 1. The total number of marbles went down by 1. So 4/9. So now we'll take 1/2 times 4/9. What can we do when we multiply fractions? Can we simplify sometimes before we multiply?
Yes.
Yeah. So in other words, could this become, I'm just going to do it down here so I don't mess with what our actual start was. 2 goes into itself once. 2 goes into 4 twice. Can we do that?
Yeah.
Yeah. So what is the answer here? 2/9. And we know that 2/9 is what percent? 2/9 is what decimal again?
18.
Every class, what is 2 nines as a decimal? Don't even tell me percent right now. What is 2 nines as a decimal? 0.2. So we're just gonna move the decimal over 2 places to the right in between some of those 2s. So we're gonna have what's gonna be over here for our whole number part of the percent? 22. And what's gonna be over here for those other repeating 2s? 2 nines. So 22 exactly equals 22 and 2 ninths percent. We get to use the exactly equals to bar because we did not do any rounding there. Okay. How many events are happening in number 6? 3. So we have an A, a B, and a C. I wonder what we do then. Okay, so what kind? First of all, is this an independent or dependent? We need to know that. Dependent.
Yeah.
Okay, without replacement. Okay, so we need the probability of the first event, probability of A. You know what, maybe we should just do it like that. Maybe it'd be less confusing. Probability of event A. What's the probability of drawing a blue one? We've already figured that out, right? 1/2. Okay, then we need the probability of B after A. So probability of B after A. What's the probability? So we're on our second event now. What's the probability that we will draw a red marble?
39.
Because are all the red ones still there?
Yes.
They should be because we wanted a blue the first time, right? So all 3 red ones are still there. But how many marbles are there? 9 to draw from, which can be simplified to 1/3. So I gotta make sure everybody followed this first, because typically we've been going down by 1 even with the marbles upstairs. But why did we go with 3 and not 2? What's the reasoning there, Brighton?
Because we took a blue one out.
We took a blue one out the first time, not a red one. All 3 red ones should still be there, right? Okay, now we need the probability of C after A and B. So after A and B, because we got a third event that went on here. So probability of C, we want a green. How many greens are left in there? 2, because we did not want to draw a green one the first time, did we? We didn't want to draw a green one the second time. So in reality, all the greens are still in there? Yeah, 2. But we've drawn 2 marbles out and not put them back. So we have 8 left. That's 1/4. Okay, now we're ready to multiply finally, aren't we? We have 1/2. We have this one times 1/3 times 1/4. Right?
1/24.
1/24. We have 1/24 probability that we're going to draw a blue marble, then a red, then a green, and none of them are going to be put back. And then we're going to take that and round and try dividing it out and see what happens. Anybody? Oh, there's another repeating decimal I can teach you guys. Okay, what happens on the calculator this time? Give me some. Right, what happens?
0.041 and then 6.
And then this 6 keeps repeating? Okay. I want you to do something for me on your calculators. I want you to take 1 and divide it by 6. What's 1 divided by 6? This is what you said. 0.61 and the 6 keeps repeating? Oh, so is this part right here? Is this part right here 1/6?
Yeah.
It is, isn't it? So when we move this over to, we now have 4 and 1. There's another fraction. We can know what its decimal name is. It is 1/6 with a repeating 6. And that one should be easy to remember. 1 upstairs, 6 downstairs. Okay. So this one is exactly 4 1/6%. Okay. So, anybody have any unanswered questions? Something still not